Hello everyone and welcome back. Today we're looking at section 3.8, functions and relations. So in class we kind of got to start talking about this, right? The idea that a relation has a lot less stipulation to it, okay, than what a function does. So in a function, right, it's a correspondence between two sets D and R, which are domain and range. Okay, these are your inputs and your outputs. Okay, that assigns to each member of your domain exactly one member of the range. So that's the key here, is that for a function, each x value you put in, you can only get one y out. Or each input you put in, you can only get one output. Now you can have multiple inputs go to the same output. That is fine. But you can't have a single input that goes to multiple outputs. In class, we talked about what this looks like visually. So visually, if you think about a graph, if you look at a graph and you're looking across the graph, there's no spots on a function where if you drew a vertical line, it would hit more than once because each x value can only have one y value. So let's take a look at some examples of some functions. And I mean, you guys have done a lot with this in the past. You've even used the correct terminology in the past. We're just going to go a little bit deeper today. Okay, so here we have a function defined by the function f and the function g. So this is f of x and g of x. Okay, for both of them, all real numbers is the domain. And we'll talk about what can dictate the domain here in a minute. So this right here just simply means you're going to put 10 in for your input into the function f. So I'm going to do 5 times 10 minus 1, which is 50 minus 1, or 49. And that's all I have to do in that kind of a problem. Now this next one says g of 7. So I take my function of g and then I put 7 in for my input. So 7 squared plus 2, which would be 49 plus 2, which is 51. Okay, the next part, these are composites. So this is where you have more than one thing to do at a time. And just like all math, we start with our innermost parentheses and we work our way out. So we actually have to put this 3 in for f first, and then whatever we get for that, that's what we put in to the g function. Okay, so the way you read this is g following f with an input of 3. That's the way we have to look at this. So we put 3 in for f, so 5 times 3 minus 1, which is 15 minus 1, which is 14. So now I have to put that in for g. So now I take 14 squared plus 2, which is 196 plus 2, which is 198. Now for D, it's the same exact thing, except we're going to put it into G first and then take our solution to that and put that into our F function. So our G function, we're going to do 3 squared plus 2, which is 9 plus 2, or 11. But now I'm going to put that in to my F. So that goes, so this is going to really put in 11 for my input into F. So that's 5 times 11 minus 1, which is 55 minus 1, which is 54. Now, in the homework tonight, you're going to see some additional things. Like you'll have like an f of 2f times, 7 or of 7 or whatever. So that just means you put 7 into the function of f, then you're going to multiply whatever answer you get for that by 2, and then you're going to put whatever that answer is back in for f. So don't let that confuse you. You start in the center and you work your way out. Okay, innermost parentheses on out, just like you always do. Now the other thing that they're going to talk about in the homework tonight is your domain. So there are times when the domain of a function gets restricted because there is something that happens. And the two most common cases where this happens is where you have square roots and where you have fractions. Okay, so square roots and fractions are the two biggest cases. And the reason why is that you need to take the square root and get a real answer. That square root or the number has to be greater than or equal to 0. Right? So we need x to be greater than or equal to 0 in those cases. Okay, here, b can be anything except one thing, right? What's the one thing we can't divide by? Well, it's 0. Okay, so those are the two cases that would cause us to really need to restrict the domain and the things that you've learned so far. So when we look at these, right, this one has a square root. So since we have this radical here, that means we need whatever this value is to be greater than or equal to 0. So 2x minus 7 needs to be greater than or equal to 0. So we can add 7 to both sides. 2x is greater than or equal to 7. Then you divide both sides by 2. X just has to be greater than or equal to 7/2, and then we'll be okay. So the way that I write that, right, my domain, which is D, right, for X. So we're going to put a bracket here for X such that X is greater than or equal to 7/2. So when you have a square root, it's going to be what D can be. But when we get to a situation like this, right, we don't want 0 to be in the bottom of this. In those cases, we're just going to simply say what our domain can't be. What are the values of x that don't work? So I need to figure out when will x squared minus 1 equal 0. Well, if you add 1 to both sides, x squared equals 1, take the square root, you get x equals plus or minus 1. So this again is where it doesn't work. So when we write this out, this is our domain, right, for x such that x does not equal plus or minus 1. Now, it would be perfectly mathematically correct and acceptable, okay, if you wrote it as x such that x does not equal 1 and x does not equal negative 1. Either one of those is a perfectly acceptable answer. C is another example with a fraction, so we've got to worry about this bottom here. So we want to know when can this equal 0. So when will that equal 0? Well, this is a easily factorable one. So the only way to get x squared is x and x. We're looking for the factors of -6 that are going to add up to -5. Well, that's -6 and positive 1. So then when will this whole expression equal 1? Anytime either part of it does. So when x equals 6, it would equal 0. And when x equals -1, it would equal 0. So since we don't want it to equal 0, right, that's the thing we don't want, those are the things that x can't equal. So the domain for this one, right, will be x such that x does not equal 6 and x does not equal -1. Now, our last one here, notice we have no square roots, we have no fraction. Well, those are the only situations that you guys know of that could cause a problem. So that means for this one, you have 3 different ways that I would accept this. You could write it out as the domain for x, right, for all real numbers. You could just simply write all real numbers. Or if you're writing out by hand, you can use our symbol for all real numbers. Okay. Well, that's all we have today. The homework, I did make a slight adjustment to it. It is actually only 29 through 45 odd that are all loaded into Schoology. If you have any questions, please make sure you ask. Hopefully you're having a wonderful day. Thanks a lot, guys.